Hi, everyone. I figured the easiest way to have you be able to completely fill out your notes and get through this would be if I recorded the work myself. So hang tight with me, and we're going to go through and fill in your notes and talk about what ratios are and how to use a tape diagram. I want to remind you that you can pause or rewind at any time if you need to. That way you can make sure you don't get too far behind with the notes, okay? So I'm going to go ahead and get started, and we will go from there. So, chapter 5 is very exciting. You've talked about ratios before. This is not new, but it is something that we're just learning about. So, we want to make sure that it makes sense. I'm going to zoom in a little bit. So, a ratio is a comparison of two amounts. Usually, we use division to accomplish that. We can talk about different kinds of ratios. A ratio can be a part to another part. For example, if we were talking about the ratio of boys to girls in our classroom, the boys are one part of the students, the girls are the other part. We're comparing a part to a part. Ratios can also be part to a whole. This is where our fractions come in, because that's what a fraction is, a part to a whole. So if we were talking about the ratio of boys to all students, that's what we would do. Hold on just a moment, please. Okay, let's keep going. So we have part to part, like boys to girls, part to whole, like boys to students, or whole, can you guess, to part, like students to girls. So we have lots of three types of ratios um, that we look at: part to whole, or whole to part. And it's just, of course, the order that they're in. If I was asked to find the ratio of apples to pears, I have two apples and one pear. So I would say that the ratio was 2 to 1. Two apples to one pear. I have to keep the numbers in the order that we're given. So apples have to go first, pears have to go second, because otherwise you wouldn't know which was which. So you have to keep them in that order. There are three ways that we write ratios. So if I wanted to write the ratio 3 to 5, obviously we could write it in words, but the ways to write it otherwise are 3 to 5, 3 to 5, or 3 to 5. Yes, that is a fraction. Ratios, as we already saw, fractions are a type of ratio. So we use that same format. Okay. So as we're working through, it's important to recognize that the relationship in a ratio. All right. So let's try this again. Hopefully, we are still looking at the correct thing. That was the plan. Hopefully, we're still sharing the correct information, because that would be really frustrating if it wasn't. All right. So, in order for it to be a ratio, it must have two or more numbers. You cannot give a ratio that is only one number. So, for example, if I write the ratio 2 to 1, when I write it, I can write 2 to 1 as 2 to 1, 2 to 1. I cannot say that that is a ratio that is equal to 2. That is not a ratio. Okay, we have to have both numbers. And the relationship between them is multiplicative, which means it's based on multiplication and division. You've got to keep that in mind. Okay? Just like with fractions, we can talk about equivalent ratios, which describe the exact same relationship. So if I go back to my pairs at the top here, we have a 2-to-1 ratio. If I added two more apples and one more pear, our equivalent ratio of 4-to-2 would be the same. We have the same relationship. Okay. When two ratios are equivalent, you can multiply or divide each number in one ratio by the same number in the other. So just like fractions. So when I said my pairs were a ratio of 2-to-1, and then I said I added two more of these and one more of these, we doubled what we had. So then we had 4 apples to 2 pears. Those two ratios of 2-to-1 and 4-to-2 are equivalent. Oops, you can't see that. So just like with a fraction, a ratio and its equivalent fraction, or a ratio in its simplest form, are equivalent fractions. Sorry, that came out totally backwards. All right. I'm going to pause for a second. So it's really super easy to determine if two ratios are equivalent. We can multiply both of the numbers or divide both of the numbers by the same thing to get the other ratio. So for example, in example number 1 here, we have 1-to-3. And we want to know, is that equivalent to 5-to-15? Well, if I multiply 1-to-3 by 5/5, I get 5-to-15. So the answer is yes, those are equivalent. If I take 2-to-6 and I want to see if it's equivalent to 4-to-12, I can scale up. I can also use something called cross products. And it's very similar to cross canceling, except we're going a little bit differently. So we can take 6 times 4 and we get 24. And we can take 12 times 2 and we get 24. We have the same cross products, so those two ratios are equivalent. So you can figure out what to multiply by or figure out what to divide by in order to see if the ratios are equivalent, or you can use cross products. Okay, so let's try one more example here. We've got 2-to-4 and 3-to-5. I'm going to go ahead and use cross products. I think it's quicker in the long run. So we have 4 times 3 is 12, and 5 times 2 is 10. They're not equal, so the answer is no, those are not equivalent ratios. Just like with a fraction, if I give you a ratio and ask you to write an equivalent, as long as you multiply the numerator and denominator by the same number, you can multiply anything by anything you want. So I could multiply by 2/2 and get 10/14. I could multiply by 25/25 and get 125/175. They're still equivalent. So ratios really are just that relationship. How do I compare this to this? Okay. A lot of times when we're working with ratios, we use what's called a tape diagram. And they can be super helpful in helping us figure out ratio problems. So it literally looks like pieces of tape, or like two pieces of tape that we've kind of drawn on. Okay. And it shows that relationship between the two numbers again. So our example here says the ratio of your monthly allowance to your friend's monthly allowance is 5-to-3. So what we're going to do is draw 5 segments for you. And we're going to draw 3 segments for your friend because yours to your friends is 5 to 3. Altogether, they total $40. So the 8 parts altogether equal $40. Okay. So we know if we look at this diagram that we have $40 in 8 parts. So to find one part, we're going to divide. So that would, the $40 divided by 8 boxes means that each box is worth $5. So if we go back in, we can label each box with its total. And then we can figure out each amount. So for you, you've got 5 boxes, which are $5 each. So your allowance is $25. For your friend, they have 3 boxes that are each $5. So their allowance in this case would be $15. And together you total 40. Let's look at some more examples. Okay. Hold on, please. Okay, so let's do some examples. It says Eric and Tyrone shared $72 in a ratio of 3 to 5. So the first thing we need to do is set up our bars. You always need to label, even if you just did E and T, so that you know which is which. So the ratio is 3 to 5. It's going to be 3 to 5 because that's the order they're in. So we're going to draw 3 boxes for Eric and 5 boxes for Tyrone. And we want to try and keep the boxes the same size. It's a little easier to do on lined paper, but that's not too terrible. Okay. So they shared all the money. So all the money is $72. And they want us to figure out Eric's share. In order to do that, we need to count how many boxes we have. We've got 1, 2, 3, 4, 5, 6, 7, 8. You can also do 3 plus 5. So to figure out what each box is, we're going to take our total and divide it by how many boxes there are. And that's going to tell us how much per box. So I'm going to go ahead and fill in my boxes with 9s. Now I can see that for Eric, he has 3 boxes times $9 each. So $27 of that $72 belongs to Eric. Sorry, I keep twisting the paper so it's crooked. Okay. Let's look at the next example. It's been a busy afternoon. Okay, so the ratio of boys to girls in the 6th grade is 4 to 7. So we have boys to girls, and it's 4 to 7. So the boys need 4 boxes. Cut it in half, cut them in half. The girls need 7. So that's 4, 5, 6, 7. We'll do that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Not very even, but you get the idea. Okay, so 4 to 7, boys to girls. There are 88 students in the 6th grade. This is not Eisenhower math, it's just numbers, just in case you're curious. So all together, there are 88 students. And we want to know how many are boys and how many are girls. In order to do that, we have to recognize that we have 88 total, and we're dividing it by 11 because 4 plus 7 is 11, which means that each box is going to be 8 students. So 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8. We can then figure out our numbers. So boys were first. We have 4 boxes times 8 per box. Means there's 32 boys. For the girls, we have 7 boxes with 8 per box, not boy box, which means we have 56 girls. And if we double check, 32 plus 56 is 88. So the ratio of 4 to 7 gives us 32 to 56 as an equivalent ratio. So that is using a tape diagram to find parts. Now we're going to look at using a tape diagram to find the whole. It's a little bit different, so stay with me. So in a necklace kit, there are 2 gold beads for every 3 black beads. There are 36 gold beads. So in order to figure out how much is in every box, we're going to divide by 2 and get 18. Now, we know there's 18 here. They have to be equivalent. So there are 18 in each of these boxes as well. So to figure out the total now, we have 5 boxes of 18. That gives us 90 beads total. So we used what we knew about gold beads, recognizing that in every model we make, the boxes have to be the same size. If you look back really quickly at our previous boxes, all of them were 9, all of them were 8, all of them were 5. So the boxes in the tape diagram have to be the same amount. So if these 2 are 18, then these 3 have to be 18. And that's how we're able to use it to figure it out. So Scott was making punch for a picnic. He mixed pineapple juice and ginger ale. So I'm going to be lazy and label pineapple juice and ginger ale with a ratio of 3 to 2. So I need 3 boxes for my ginger ale, or my 3 boxes for my pineapple juice, because it's pineapple juice to ginger ale, so 3 to 2. So my ginger ale is going to be 2. We know, according to the problem, that Scott used 6 quarts of pineapple juice. So if we know that 3 boxes equals 6 quarts of pineapple juice, then 6 quarts divided by 3 boxes is 2 quarts per box. And remember, they have to be the same. All the boxes are the same size. So we could figure out that ginger ale is 4 quarts. The pineapple juice is 6 quarts. So we have a total of 5 boxes of 2 quarts each. which is 10 quarts of punch. And the diagram just really helps you make the connection. And yes, you are going to need to be able to make the diagram, whether you want to or not. You have to know how to do them. Next problem. The ratio of trucks to cars in the parking lot is 2 to 5. So we're going to do trucks to cars is 2 to 5. It says in the problem there are 40 cars in the parking lot. So we're going to take 40 cars and divide it by 5 boxes to get 8 cars, 8 vehicles per box. So 8, 8, 8, 8. That word just sounds funnier and funnier the more you say it. So again, we're asking for the total number of vehicles. So we could do 16 plus 40. We could do 7 boxes of 8 vehicles. Either way, it's a total of 56 vehicles. Oops. I'll give you a minute to look at that. And we have 2 more examples and then we're done. So hang tight. Remember, you can pause as you need to. All right. So we're going to bump it up a tiny bit more and do some slightly different ones. So we now are making trail mix. And we have almonds, sunflower seeds, and raisins. You don't have to like them. The ratio is 2 to 5 to 3. Yes, that is the thing. You can compare more than 2. So our ratio is almonds to sunflower seeds to raisins. So we're going to start by drawing 2 boxes for our almonds. Thank you. And we are going to do 5 boxes for our sunflower seeds. And we're going to do 3 boxes for our raisins. And again, try to make the boxes even, but it is not easy. So it says there are 10 ounces of sunflower seeds. So all of this bar equals 10. And we have 1, 2, 3, 4, 5 boxes. So that is 2 ounces per box. So 2, 2, 2, 2, 2, 2, 2. And they want to know the total weight of the trail mix. Well, we've got 2 and 5 is 7, and 3 is 10 boxes with 2 ounces in each. That gives us 20 ounces. I know I'm cursive and then back and forth. Sorry about that. Okay, or you could figure out 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 to double check. All right, let's look at one more. The ratio of ages in years of 2 teachers is 8 to 9. So we're going to call them teacher A and teacher B. This is a lot of boxes. I'm going to divide it in half, cut those in half, cut those in half, kind of in half. And one more box. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I didn't mess that up. The sum of their ages means the total is 51 years. What is the age of each teacher? Well, we've got 8 and 9 is 17 boxes. So we're going to do 51 years divided by 17 boxes. And that is going to be 3 years per box. So fill them in however you want to do it. Now we want to know the age of each teacher, so we're back to finding the parts. So teacher A has 8 boxes times 3 years per box. So teacher A is 24 years old. Teacher B has 9 boxes times 3 years per box. So teacher B is 27 years old. So that is how we use ratios to make comparisons and tape diagrams to demonstrate or display those comparisons and to make them more visually available to us. So you're going to be doing a little bit of both of these in your station work today. And I think that you're going to find that it is pretty simple, but you need to pay attention. If you need to go back, not only can you go back and watch parts of this video again, there are also other videos in the station. All right. Have a great day. Please work hard for the sub or the teacher that's subbing, depending on how that works out. And I look forward to seeing you tomorrow when we'll work on our Chapter 4 review. Take care. Have a great day, everybody. Bye.